Okay, welcome everyone. So today I'm just going to present one of the uh, containerized application, which is I am just going to deploy on Google Cloud. So I would like to show you how it does, how it works, and deploy on the Google Cloud. So that is the agenda of today's meeting. So I'm just going to share my screen. Hope everyone can see my screen.
Yeah, go ahead. We can see.
Okay. So this is POC number 4. Actually, I already created 3 POCs before with the Google Cloud, and this is a part of containerization application, and I'm going to deploy one of the web application, which is actually kind of web professional portfolio application, which is on my personal professional portfolio web apps, which I just customized, and I just play around with that application. So I just a little bit play with the Docker Kubernetes, and I try to deploy with the same application on the Google Cloud. So I am presenting on that project in this session. So as it is visible that to implement highly available professional portfolio web application on GCP Cloud with the GKE, which is Google Kubernetes Engine, which is a containerized orchestration tool actually. And we will be deploying with the Cloud SQL MySQL database, which is a database backend actually. And this application consists actually dynamic web page, which is a contact page through which we will be insert some data, and we will test that how it goes into the backend and how it failovers in highly available environment. So that is the main agenda of this entire session. So let's get started. So this is a high level overview about the application environment. What is the application and what it looks like actually. There will be two-tier application. With front end tier is a web application, as I mentioned, professional portfolio application, and it is developed with the PHP, HTML, CSS, and some JavaScript inside. And actually YAML is we used for in order to deploy to the Kubernetes. We use the YAML configuration file, so I mentioned that as well. And just a moment. Okay, so this is actually going to deploy with the container environment. So definitely we are using Docker and container repository tool as a GCR, which is Google Container Registry Artifactory tool, where we build the web front end web source package, and we'll be containerize that using the Docker, and we will push to the Google Container Registry in order to deploy through the Google Kubernetes Engine, which is orchestration tool from Google. And there is a database tier, Google Cloud SQL we are using here with the highly available environment. So that's it. Let's go to the tools and technology. So this is the tools and technology, as I just mentioned above. This is all about Cloud SQL, Docker, Kubernetes, GKE, and Microsoft VS Code actually I used for development IDE, and we also use the GitHub for configuration management. There is one join. Yeah, so this is the application web application portfolio. Actually, I just wanted to show you like how it looks like when it will be deployed in the browser, how it looks. So this is the web application actually, my personal portfolio, professional portfolio, which is customized based on my requirement. So this is the home page, and this is the actually contact us page, which is a dynamic page actually, through which we will be inserting some data from the front end, this web page, and it will insert the data, it pass to the Cloud SQL backend. So once it is inserted successfully, it will look like this as shown on the right side. So it will be successful like once it is inserted. So that's it for this. And this is the solution architecture of entire deployment process. So how it actually going to process entire in the cloud. So as it can be seen, there is a cloud shell on top left. That is using the cloud shell, we are utilizing using the cloud shell, we will be containerize the web source code, and we will push that to the Google Container Registry, and from there it will be deployed to the Google Kubernetes engine. So this is the architecture as it shows. This is a Google Kubernetes engine, and there is a Google Kubernetes engine cluster actually. We'll be deploying that cluster, and I will show that hands-on as well. I'm just giving a high-level overview so that you can have some better insights what is we are going to do in this session. So I will be sharing the entire documentation as well, which I prepared step-by-step procedure, each and everything, so that you get to know how it works actually. So as it can be seen inside the Google cluster, we will be deploying 2 worker nodes, and in each worker node there will be pods, and inside the pod we will be deploying that Docker image which we built from the source code, right? So that is it. As it can be seen, my portfolio application is displaying inside the pod. So that is the high level overview. And once it is deployed inside the Kubernetes engine, we have to deploy one more service along with that, which is a load balancer service, because this has to expose the from outer world as well, because so that people can access the website from anywhere, right? So using this load balancer service, we will be deploying that so that with the external IP user can access. So as it can be seen on the left side, user is trying to access, and there is a cloud external IP address is there, and there is a cloud load balancing service is there, which is trying to access the service load balancer inside the Google Kubernetes engine. And it will expose the external IP and port, and through which the user will be able to access the website. And let's move to the database side. So there is a Cloud SQL databases will be deployed inside this Google Cloud environment, and there will be it will be in multi-region, highly available environment, because we have to check test the failover as well. So in that case, like the application should be like highly available all the time, with this zero single point of failure. And for that, we are taking a 2 different region here, like as it can be seen, Asia Southeast 1A, Asia Southeast 1B. So once we start the failover, let's say we are failing over on Southeast 1A, it will immediately replicate and transfer the traffic to the Asia Southeast 1B. So that is what we are going to see as well with the highly available failover testing. So in that case, our application will be highly available. It will be still up and running all the time. So that is all about the solution architecture. Let's move to the next. So this is the agenda. It is all about like phase by phase procedure I have mentioned here, like in what phase, what type of action we are going to do, and how it is going to achieve. So in phase 1, we will be building a web app source code from local and push to the GitHub. Phase 2, we'll be downloading that source code from the GitHub inside the Google Cloud shell. And once it is downloaded, we will containerize the web app using Docker image, and we will push that to the Google Container Registry. In phase 4, we will be deploying a Google Cloud SQL database, MySQL, with multi-region. in order to establish the connection. And phase 5 will be Kubernetes cluster we have to deploy, and with the deployment and service YAML, so that our application will be up from the Google Kubernetes cluster. And phase 6 will be deploying application YAML to GKE and access the web application from the browser, and we will do entire testing. And phase 7 is a test application, highly availability using Cloud SQL failover test, which I just mentioned about. We'll be doing, and we will fail over one region and we'll be start testing to another region. So that is the agenda of the phase 7. GKE overview, as GKE is the Google Kubernetes Engine, is a orchestration, managed orchestration tool from the Google, and it is very powerful as it provides many features, and some key features I have tried to mention here. Let's say it provides like autopilot and standard, those two kind of services it is provided right now. So autopilot mode, we'll be utilizing autopilot in this session because we don't need to manage anything, any networking or any other services in this session. So that is why we'll be using autopilot. There will be pod and cluster auto scaling as well. So in order to achieve high availability from the Kubernetes, we need to auto scale the cluster, right, with some replicas so that it can always highly available. It will also provide some pre-built Kubernetes applications and templates, container native networking and security, migrate traditional workloads to GKE containers with easy. So that is the features of GKE actually. I just tried. Yes.
Like this is, you're talking about the Google, right? Like
yes.
We can have a similar thing for Azure as well, right?
Yes, definitely. Every public cloud has its own services. Let's say Azure has its Azure Kubernetes service, which is called AKS. Okay. And Google has GKE, Google Kubernetes Engine. Let's say AWS has EKS, Elastic Kubernetes Services. So every public cloud has its own Kubernetes managed services they provide.
Yeah, okay, go ahead.
So this is all the phase I just mentioned step by step here. We will be doing action and we will follow through. Let me actually show the document which I prepared. So it will be, I hope everyone can see this document as well.
Yes, we can see it.
Okay. That's fine. Yeah. So this is actually a detailed project documentation which I built, created an entire step-by-step procedures through, so anyone can follow and deploy their own way as well. I put like lots of efforts behind preparing and everything. So this is it. So project definition, again, I am just taking over like imaginary company, and it has a requirement like there's a professional portfolio has to deploy using Google Cloud Kubernetes Engine. So that is it. I have just written some detailed high-level overview in that. Again, application environment, and there is a solution description as well. So someone can have insights like what is going on inside. So this is the architecture we just discussed, all the phases, and this is the main thing. Like I have prepared each and every steps and action in terms of snapshots. I have provided here guideline, everything step by step, what has to be done. This is completely detailed document, and now we are going this into action. Okay, so let's move to the Google GCP console and let's get started. I hope everyone can see the console as well.
No, only we can see document, not the console.
Not console.
Not yet.
Check. Okay, now
Yeah, we can see it. I can see it right now.
Yeah, it's a Google Cloud Platform.
Google
right?
Cloud Platform. Yeah.
Yeah, we can see it.
So this is the GCP Cloud Platform, basically. And we are just going to see everything in action, whatever I just described in the presentation, and we are going to achieve this complete project. So let me follow side by side the documentation as well, so that you can have some better insights. So first phase is like build a web app source code from the local and push to the GitHub and prepare front-end web application source code from VS Code. So I'm just going to show how I prepared inside the VS Code. So okay, actually I got the timing limit, which because we are just half an hour. I think 10 minutes it will be over. I didn't aware about the limitation of this Zoom. Okay, anyway, let me show you where is my project. So this is my project actually inside the VS Code. This is index.html page, and this is the db.php and everything. We'll be seeing that. So this is completely dynamic page. I created the contact page, and this is the connection string with the MySQL, because this is most important in order to establish the connectivity and expose the environment variables to the Google container and Docker container and Google Kubernetes engine. So this is it actually, and I will be showing that how we can mention and configure each and everything. So I pushed this code already on the GitHub here, and I already cloned it. So let me get started inside the console. Let's open. Cloud Shell is just preparing the environment. Yeah, it is up. So just showing like how I have already downloaded with the git clone command. You can download the source code inside the Cloud Shell, and I have already done that. So this is the directory which we have to use here. So let's change to that directory. It contains src folder, Docker file, and YAML file. So under the src, everything about the source code. See all the necessary files here with the contact.php, emp, and everything, index.html and everything. So we just have to build the code Docker image right now. So commit all changes. Yeah, this phase already done. Now we have to download the source code. Already I downloaded, so that don't need to be done. Containerize the web app to the Docker image. That is what we are going to do here. We are just building a Docker image using this source code. So in order to build the image, we need to move to the directory where our Docker file present. So I have already prepared the Docker file. Let me just quickly show you how Docker file looks like. So this is the Docker file actually from PHP 7.3 Apache. I will be taking that base image, and I will install this with the run command. I will install Composer, and I will copy that my source code. Actually, this is the source code we are just copying inside. So if you see here, this src folder contains every necessary files and configuration files which is necessary for to deploy the web application. So this is the src. It will be copied inside the var www.html in the Apache directory, and we will expose this on the port 80 and port 443 as well. So this is the Docker file actually through which we'll be building the Docker image. Command is, I'm just giving a name, so whatever, just relevant name. It authorize. Let me show you inside the documents as well. Whatever I did already, I mentioned each and everything. So as it can be seen, it is Dockerizing. See, the build is in progress. It is building the Docker image locally actually. And once it is built, the local image will be pushing inside the Google Container Registry.
So I have a question.
Yeah.
So like, do you have to use Cloud Shell, or you can use like a local computer terminal and then push the Docker image to like Google Registry?
I think you can use, but you have to configure the credentials as it can be seen within the GS code as well, VS code as well. You can configure the Google Cloud secrets, and you can integrate with the cloud directly from your VS code.
Oh, okay. So that need configuration. To avoid that, we can just use the shell.
Yes, yes.
Okay. Also, like, there's only 3 minutes left for this meeting. So once can you send a new link to us? It's really interesting stuff. So
yes, actually, we were just half hour late, and it is going to expire. I didn't aware about that. Yeah, I will just, once it is expired, I will recreate right away, and we will reconnect.
Yep, sounds great. Thank you.
So I think those 3 minutes left, right? Yeah. So
we can start another. Meeting.
Yeah. I think it will be better because it is only 2 minutes left, and we will not be too much. Yes.
We can hold and we can restart new meeting. Yeah. You can send us. Yeah.
Yes. Okay. Yeah. Let's stop here then, and we will just restart. Okay. Okay, welcome back everyone. I am just, we already discussed the project, a high level overview and everything. I'm just sharing the screen again. Hope everyone can see the GCP console.
Yes.
Yeah, we can see.
Okay, so let me just revise. This is the project actually we are going to deploy in a containerization Kubernetes environment. It is a portfolio application, professional portfolio application, and we are just going to achieve that in a Google Cloud highly available environment. We already built a Docker image from our source code. So let's move there. Showing successfully built. So let's see Docker. So you can see PRP portfolio -app -v1 is showing their latest with the tag latest. Do you see? 17 minutes ago, we just built the Docker image. See, this is the image we just built. So now we have to push this image to our container registry. Let me show you container registry actually, so you have some understanding where we are going to push this. So this is the container registry from Google. Once we deploy push that image, it will be shown here somewhere, and it will be private registry, right? So let me push that. First of all, let me give a tag. Okay, so for the identification. Source images. Show you.
When you say container registry, what does it mean by?
Container registry is a kind of storage artifactory. Once the code is built, like source code, all the web application which contains like index file and everything, configuration file in order to run on the as a website, right? So all those files are like a separate files, right? But in order to deploy on the server, you need to have kind of container package. You need to package basically, and in that package you have all those dependencies are mentioned, and where it is going to run with the port, and on which OS it is going to run. Those kind of things, configurations we are mentioned inside the container. So with that, the image is built with the container. It can be run on any kind of like without any dependent environment. It is kind of decoupled environment we can run. So let's say there is a virtual machine like bare metal virtual machine or server in the earlier days, right, and earlier years, right, and we have to deploy that code with like kind of we were just pushing the code using the SCP, or copying the code inside the server directory using the SCP tool, and we were copying those kind of things. But with the Google container, like Docker container, we are just building that, taking that source code, and we are building as a container package, and all that package is going to deploy inside that server. So we are just tagging the image. So this is the command actually you need to follow in order to tag. I'm just tagging gcr.io. GCR is nothing but a Google Container Registry. We'll be building along with the project name. So this is our PRP GCP, and Anthos is our project name. So we are passing this as a project name. Giving again PRP. Is tagged.
Praful, I think there was a spelling mistake before, but you would have.
Where in the
When
tagging?
you wrote the Docker tag, right? PRP portfolio, it was PRPORTFLI.
Yeah. Oh yes, yes, yes. Portfolio. Yeah. So yes. but I think it is good. Yeah, that won't be any problem because the source image has the same name, right? I made a mistake there.
No,
So
no, no. No, I just mentioned so that, when
yes,
you're writing it again, I just didn't want that to error out somehow. Okay.
yes, yeah, that is true. Okay, so now we have our Docker images tagged. In this terminal, we have to be like careful when we are typing. Okay, we are just pushing this to our container registry. So this is the container. Actually, it will be here soon. So this is, we are just pushing. See, the pushing process is just started. Yeah, and it will be here. Let me refresh. See, PRB portfolio app one, test one. So inside there is a Docker container image. Inside this image, we have our source code, web application source code. Okay, so we are done with what phase we complete. So we containerize the application in phase 3. Now phase 4, we have to deploy Cloud SQL with multi-region, right? So let me create, deploy Cloud SQL. Let's just leave this Docker image. We will come back and we will do some things and we will deploy to the Kubernetes. So let me first open the Cloud SQL. I'm just opening new window so we will easily switch between those windows. So in order to create a Cloud SQL database, we need to click on create instance. See, and we'll be choosing this MySQL. There is a PostgreSQL as well, SQL Server as well, but we will be going with the MySQL. So instance ID, in which region I will be deploying, let's say US Central 1, let me take that. For anything, I'm just providing test, database version 5.7, single zone or multi-zone. So we are going to deploy with multi-zone so that we can have highly available without single point of failure. So it will be replicated in another region when there is a failover happens, right? If you do in a single zone, then there won't be any highly available. Your application will be failed in case of disaster recovery. So have to make sure. So primary region would be US Central 1A. Secondary zone will be US Central 1B. So once US Central 1A is failed, something happened, it will be immediately switch the traffic to the US Central 1B and our application will be still up and running. So that is the logic behind these multiple zones. So let me follow to the documentation as well at the same time. See, enable HA multiple zones, all those things. Okay, machine type, we don't need high memory, just lightweight is enough for this project. Storage, will 10 GB is enough. Connections, okay. For database, it won't be public IP, right? Because we don't need to expose the database for our external world because anybody can hack easily, right? So always have to make sure there's a private IP so nobody can talk to our database tier. It will be always private. Network, we will just select the default network. Backup maintenance, we don't need to choose anything right now for this project. I would just click on create instance. So instance is being created. So meantime, when the instance is in progress, let's do one test, which we didn't do. So this application Docker is already pushed here, and we have to test now. Okay, let's verify if the web application is successfully built inside this Docker image. So how we can test that? So let me show you how we can test whether our web application is successfully built inside, and we can access that using the browser. So let's go here, and I will do Docker run port, host is 8080, and have to expose on 80. And what is the name of our container? So this is the name. Remember this, I just give the tag name. So that is we have to provide here. So it would be gcr.io, then again score ID and PRP. Okay, here I have to remember because I made a mistake, right? Portfolio. Okay, Docker run has just started. Let's see the documentation as well. So this is about test, how you can test the Docker. Okay, we just forget the latest tag as well to mention. Okay, now let me access on using the preview, web preview on port 8080. Oh yeah, boom. You can see the web application is successfully opened on browser. So with that, our Docker image is successfully built and pushed on container registry. See? So this is just my portfolio web page actually. And this is our main thing where what we are just going to test contact form. Actually, this we haven't yet complete. We have yet to configure the database and Google Kubernetes engine, right? And we have to deploy this application on the Kubernetes engine with Cloud SQL database. We haven't yet done. This is just the sample web page. Nothing happened yet. Actually, let me show you what is happening if I do right now. Test. It will give an error. See, failed to connect to MySQL because there is no database connectivity yet, and we haven't deployed it to the Google Kubernetes. So that is what we are going to achieve with database and GKE. So let's just see if the database is up and running. It is still in progress, creating. Let's just go through the documentation. Okay, we have successfully completed this up to here. Docker run, web application is successfully displayed on web page. So Cloud SQL is in progress. Okay. Once database is successfully deployed, we have to create one database inside this instance. Actually, this instance is being created right now. This is still running. Actually, you know, this is taking some time to create the database instance. So once it is deployed, we will create a database inside and user as well in order to access the application from front end. It is still up running. I hope everyone is clear up to here so far. Hello?
Yeah, Praful, I think we are good so far. Yeah.
Okay, okay. Yeah, I thought maybe there is a voice issue or something.
No, we can hear you.
Okay. Yeah, so far we have achieved like using the Docker image, the web page is displayed and there is a database connectivity is left, and we have to deploy. The actual magic is going to happen with the Google Kubernetes engine. Once we deploy this entire working application with the Kubernetes, right? So let's see, database is up. So how to create a database? So let's see, empdb database name. I am not changing anything here. Also, I'm not changing here. Just click on create. It will create a database, empdb. We need to have one user as well to access our application with the database, right? We are not going to use the root. So user will be app user, and password will be test, and it has to allow any host, otherwise you know there will be issue. So it will talk to any host without any permission issue. So just click on add. So app user is up, completed. Now what is the next phase? Phase 5, create a Kubernetes cluster and prepare deployment and service YAML. Okay, so let's move to the Kubernetes engine. So this is the Kubernetes engine. Let's follow through documentation as well, so you have some better understanding. So go here. Okay, create a GK Kubernetes cluster. Click create. As I mentioned, there is a two different options here, GK standard and GK autopilot. So we are just going to utilize autopilot here. We don't need to do any headache, manage all the inside networking and those kind of stuff. We are just configuring automated way. So click configure. Just name stay as it is, US Central 1 region, because we already deployed our database inside the US Central 1, right? So it is good. Public cluster, networking option, we don't need to change anything. Default is good, unless and otherwise there is a requirement. Definitely in a real time, we don't do default network. We create our own virtual private cloud and those kind of things, and subnet range and everything we defined as per the company's requirement. We don't do play on default. This is just the demo POC purpose I am just using. Okay, yeah. So once it is done, let's do create, and it will also take some time actually. By the time, let's follow the documentation and what is the next steps. So yeah, let me show you how once the Kubernetes cluster is up, inside the cluster, we need to deploy our application. So how we are going to achieve that and how we are going to deploy? So let me just quickly show the architecture. So once the Kubernetes cluster is up here, there will be two node will be deployed inside, worker nodes, and inside that worker node we have to deploy, there will be pod, and inside the pod we will be deploying our that Docker image which contains our web application front end source code, right? So that is the thing, and that will be achieving using the YAML configuration file. Let me show the YAML. So this is the PRP portfolio -app YAML configuration file, and this will do our work automated way. It will be deployed our entire application along with the database automated way inside the Kubernetes engine. So this is the actually structure and format of the YAML standardization. So API version v1, and this is kind of service. And the service name would be PRP portfolio, whatever relevant name you have to provide. Oh, again 10 minutes. Okay. Let me see if cluster is up. Okay, so this is service block, and this service block actually is needed because we have to expose our application for the external world, right? So we have mentioned the port 80 here, and there is a deployment block here. So inside this deployment block, entire logic will be mentioned here for the deployment inside the Kubernetes. So kind is deployment, name would be PRP portfolio, and this is the replica actually. Where is the replica? Okay, this is the replica. So in order to achieve high availability for Kubernetes, you need to mention the replicas more than one. So let's say if your application is running inside one pod and there is something happened, disaster recovery, it won't be highly available, right? So you need to mention 2, 3 or something like that. So once your one pod is destroyed, your application will be immediately available to the second pod as well at the same time without any delay. Even user won't notice anything. So that is the logic of these replicas inside this deployment YAML file. And this is the container section. And inside this container section, that is where we are mentioning our Docker image file. Do you remember we created image, Docker image, and we deployed the Google container registry here. This is our image file inside container registry, and we gave the tag as well, right? So this is the thing we have to provide here. And inside this image, we have our application front-end source code is resides, right? So this is it. And container port, again 80. And this is CPU and memory for our container. And this is the environment actually for database connectivity. This is most important thing for database connectivity. And you need to change inside your application source code as well. I mean to say you need to provide some unique way so you can definitely expose your environment variables such a way that your configuration parameters are successfully configured inside containerized environment. So as I showed you earlier in our application file, source file, there is db.php, and we have mentioned this MySQL, DB host, DB port, all these kind of parameters here which contain some value, configuration strings and everything for database, right? So same thing we have mentioned here in Docker YAML configuration file, so it can easily connect with the database. See? So remember our DB name was empdb we created, and MySQL DB port is connecting on the 3306, and the DB password is test. We created the MySQL user, right? App user, so it can talk. And this is the DB host actually. So this DB host is coming from cloud SQL instance. Okay, here our instance. So this is the private IP which we need to provide inside this configuration value for DB host. So right now it is 3, but it was older. I have to provide this, right? So it can directly connect our front-end application with database using this host machine. And it can talk with this app user, this password, and this port on this database, so that we can have the connectivity with the front-end web application with the cloud SQL database. And this is the main part of service block, where we have to, in order to access our application from the browser external world, we have to deploy a load balancer service inside the Kubernetes, so that our application can talk on port 80 on front-end browser. Otherwise, we won't be able to access from the browser once it is deployed inside the Kubernetes engine. So this is most important thing. So now let's see if Kubernetes engine is up. Yeah, it is up. How many minutes we have left? I think 4 minutes left. I think we won't be able to complete within 4 minutes the actual part.
You can continue. Sometime it will extend.
Do you mean we should continue, right?
You can continue, but if you disconnect, then we can create another login, right?
Okay. Then let's do some quick. Actually, let me show you workloads. Inside the workloads, there is nothing right now. Once we deploy that YAML file, it will be here, and the load balancer will be here. This service will be here inside this service and ingress block. So now let's go to the Cloud Shell to do the magic. Let's check the Kubernetes pods. kubectl get pods. It will display the pods, how many pods are there right now. It won't have any pods right now because we haven't yet deployed the application inside the GK. Okay, in order to establish the connectivity, we need to do one thing here first. Connect Kubernetes engine with the Cloud Shell. We have to provide this string here first, then it will talk to Cloud Shell, otherwise it won't. Yeah, credential is configured. Now let's see. Get pods. No service found in default namespace. See, there is no any pods because we haven't yet deployed the application. Check the nodes. How many nodes are there? See, there is 2 nodes are ready, and inside these nodes, our application pods will be running. So these nodes are actually in the diagram. These are the nodes, 2 nodes inside this cluster. These are 2 nodes. These 2 nodes, and inside that 2 nodes there will be pods, and the pod has Docker image and application. So that is what we are going to do and achieve. So let's configure that YAML file. Okay, I have already PRP portfolio.yaml file configured here. Let me some changes because we have to change our Docker image file, right? Okay, this is same thing. We don't need to change, except we have to change this image name. And I think I did mistake or something in providing the name at the time of tagging. PRP portfolio F1. PRP portfolio F1. I think we are good. We don't need to change anything because it is correct. Yeah. So let's do now. Let's deploy. Oh, there is 1 minute left. I think we won't be able to deploy because once we deployed, it will be like gone.
Let's start a new one, Praful.
Yes, I am just yeah, let's disconnect and immediately I will create a new meeting. So we will have, because our final thing is left, right? Without recording the major core part, and there isn't any much thing left here. We are just and end of that part, and you are just closer to do that magic. So yes, let's disconnect right now, and I'm just creating a new meeting. Stay tuned.
Okay, thanks.
Okay, thank you. Okay, welcome back everyone. We are just starting from where we just left with our Kubernetes deployment project. Go to the Cloud Shell. Hope you are seeing the console, right? Are you able to see the console?
Yes.
Okay. So, yeah, so once the cluster is deployed, it looks like this Kubernetes cluster engine. See? Networking and stops, workloads. Workloads, it will be displayed here once we deploy our application. So we are just going to deploy our application inside the Kubernetes engine. So let's get started. I'm just the YAML file. I already mentioned and explained the YAML file, right? So just with this command, SF. So once I hit this command, it will deploy our application inside this Kubernetes engine. So the YAML file is contains this. Okay, you know, one thing we forgot actually when this disconnection was happened, we had to change the connection strings for database, right? Okay, so this is the connectivity IP address of the database, and we need to change inside our YAML file for DB configuration. So this is here the value to make sure that it is correct. 103.2422.2422. Yeah, and everything remain value same because we just made that global unique. We didn't change that. So now it is all good. Just going to deploy now that YAML file using kubectl apply command file, and once it is done, the pods will be deployed and the image will be deployed and that application will be up. So let's deploy. See, service PRP portfolio app created, deployment app is created, service PRP portfolio app is configured. So this is what it is saying actually. This service is created, this deployment is created, this service is created. This is what it is mentioning here. So now if we see, there will be some pods. See, one pod is ready and running, status is running, and the name is PRP portfolio, and this is just a random string. And now let's see the service status. Get service, this is the short form. So this is the PRP portfolio app, and it is exposing on the load balancer cluster IP this, and external IP is this. So external IP is still in pending. It will take some time, and it will be, once it is displayed, we have to grab this IP and we have to go to the browser, and then we will be able to access our application. So let's show you same thing in the console. So here you will see the deployment will be seeing here. See, PRP portfolio app is displaying here as deployment inside this cluster. So this is the deployment of our application. It is showing all the overview of performance. See, this is the load balancer, and this is the endpoint is configured. Let's go to the services and ingress. It is also configured. See, and this is the endpoint at load balancer external IP. See, external endpoints type load balancer. So let's correlate the same thing with our diagram. So you see this user will be accessing this cloud external IP addresses, and using this IP address, it will connect through the cloud load balancing, through the service load balancer, and it will connect inside this front-end application, which is inside the node pod. So this is the load balancer, and this is the external endpoints. If I show you here now, it will be showing now. See, external IP is assigned, and the same will be here inside the GUI. See, 119.24, 119.24, and port 80. So now magic is going to happen. We are going to access our front-end web application using this endpoint. Let's click and see, application is up and running. Yeah, we have successfully deployed our application on Google Kubernetes Engine with external load balancer. See, this is the same IP here and here as well. Same. So now we need to test the database. We need to insert some data, right? This is just portfolio, professional portfolio web application. I just customized. This is the dynamic contact page where we need to insert the data, and we have to test this entire project, right? So let me show you inside the document how it is going to look like. So you will have some better insights. See, web page is up. Now we are going to insert the data, and it will be displayed like this. That means if data is displayed here, that means application front end is successfully talking to the backend Cloud SQL database, and data is going to be inserted. Data is inserted inside the database.
Praful, we see a blank screen.
Oh, blank? For this, for this only, or since when you are seeing blank screen?
Just now, for this screen, the last screen that you're showing, I'm not able to see it.
Oh,
Yeah, even I can't see. It's a blank.
okay, let me just check. I think when I shared, only few screens were there. Are you able to see now? Were you able to see the browser when I accessed that using the cloud external IP address?
Yeah, we were able to. Once you started with the contact form, that's when it stopped.
Okay, so
Yeah.
this you can see, right? Contact
Yeah,
form?
we can see your contact form. You can see.
Okay, so now you can see the document.
Yes.
Yes.
Okay, okay, yeah, that's good. So this is the document, and we are up to here. We have successfully accessed the application from the browser, right? So now we have to insert the data, and it will be displayed like this. And if it is displayed here, that means Cloud SQL connectivity is successful, and data is going to be passed successfully, right? So let's see that. Click on add data. Who? Yeah. We are successfully connected with the Cloud SQL. See, let's enter some more. Yeah.
Hmm.
Successful. So this application is running on containerized environment on Google GKE. So now, what is the next phase? We have successfully deployed on GKE. Next phase is we have to test the failover, right, on Cloud SQL with the high availability environment. So test application, right? So what we need to do, just go to the Cloud SQL. Do you see this located in US Central 1A right now? See? So this instance is running right now, database is running right now on Central 1A region. And this application is also talking to the Central 1A Cloud SQL. Okay. Once I hit on failover, it will fail the Central 1A and it will up on next region 1B. And it will still, our application will still be able to talk to the database. That is what we are going to test here. So I am just clicking on failover, application instance name, trigger failover. See, failover is in progress here as well. Let's hit some application on. See, still able to access. It is still failover in progress. Let's test some more. The application is little bit slowing down. Slowing down. Failover is still in progress. See, it was slowed down, but never failed. Never failed. See? Otherwise, it would have been like, okay, application is not available. But in our case, it was still able to access, the user was still able to send the data inside the database. It is still failing over. If we just see here, our pods are still running. It means our application is also still running, and it can be seen here.
So, Praful, when you looked up the pods, we only could see one, right? Like, but we should be having two pods, correct?
Yes, definitely for highly available environment. But I didn't provide that for two. I just quickly create that. So I had to mention that two replicas, but I can definitely, I think, mention through the YAML as well. Let me just do that. But let me show you first of all. Do you see it's located in US Central 1B
Yeah.
database? It
Yeah.
has successfully failed over. So our US Central 1A region got failed, and immediately it turned to Central 1B, and our application was still up and running. So now again, let's test. Still able to talk. See? So that is what the magic of highly available database. And you are saying that, let me delete. If I have to delete the entire infrastructure, you know what I will be doing? I will be just kubectl delete f, PRP portfolio app. It will destroy everything. This application won't be able to access. It will be soon down with just one command. It is deleting everything. See? So entire logic is behind this portfolio app.yaml inside the YAML configuration file. See, the application is down, gone.
So,
Here,
Praful,
yeah.
as a DevOps engineer or an architect, when you're doing this whole end-to-end process, you get the YAML file from the IaaS dev teams, right? Or do you have to configure everything?
We have to configure the YAML files.
So it is your responsibility, not the development project team.
Yes. If you are deploying through Kubernetes, Docker Kubernetes, then it is your job that you configure.
Okay.
So let's just quickly deploy with two replicas. Okay, because we have just few minutes. So before we just down. So I'm just providing two replicas. So it will show, okay, two pods. Let's see that. See, two pods.
Okay.
See, so one pod is gone down, then you have always second pod. So your application will again still up and running.
Okay, but with the highly available database instances, that was the database piece of it that was becoming highly available, right?
Yes, that was database. That was completely decoupled environment. Database is separate and your front end is separate, you know?
Okay. So now we have the front end also for two instances. So there is double protection now, data back end and the front end. Okay.
Yes, both the application in highly available environment.
Okay.
With replicas, we can mention as many as pods we have to require.
Okay.
In order to achieve the high availability. See, both the pods are running.
Oh, nice. Good.
So one more thing I just show you. if I delete this pod, what it will do? What it will be do?
It will still work, right? With the
Yes.
other pod.
Yes. What it will be doing, right? You know, it will create another pod.
Oh, is it?
See, it has created another one. That is the magic, because in replicas we mentioned that there should be always 2 pods up and running. So
okay, got it.
anyhow, any one pod goes down, it will always self-creating another pods. That is the magic of containerization technology.
Okay.
Playing some music on Spotify.
Wow, sorry.
So now let's see service. This is external IP. Let's just hit C. See, our application is up.
So, Praful, where do you like that IP address for general public, right? So, how do you give like a web URL to access your website?
You know, there is a DNS service, domain name service. Have you heard about that? We are providing web URL name using that DNS service. We need to buy a domain name, right? Domain name.
Okay. Then you configure that in your.
Yes. Then I will configure that domain name against this IP address. So I will, whenever somebody access my domain name, let's say prafulcloud.com, it will always point out to this IP address.
Okay, got it.
Yeah, so behind this, whatever domain we hit here, there is always IP address is configured behind, and it always talk to that IP address. We do not see that IP address, but it always talk to this IP address.
Yes, exactly. So where do you configure it? Which screen do you configure that domain name and stuff? Is it
actually inside here? DNS service will be here for cloud. Actually, I bought my own domain name as well in AWS, prafulcloud.com, and I was playing with that. It was just expired last month.
Okay. You don't have to go ahead now because you are fighting for time, right? So
yes, this is no, but I will be coming soon with this complete with DNS and everything soon.
Good.
So that is the agenda of this session, and we have successfully failed over and deployed highly available portfolio application. So I think it was all it for this session.
This was really helpful, Praful. It was really informative for me. I had zero knowledge before coming to the session, right? And now you explained it properly, and it was really good.
Yeah, I agree with Dilip. I think it's very informative. I think we're looking for more sessions.
Thanks. We will definitely be organizing once I have like more projects. Definitely, I have been working out on more projects as well, but it will take some time to prepare such kind of documentation, detailed documentation thing. But I will be coming soon with new projects, and we will keep this journey actually ongoing. And
let's plan every weekly or bi-weekly one session like this. It's up to you. Like whenever you have complete information, we can touch base and we can continue.
Yeah, definitely. I would do that, and I would really like to do that.